Good evening, children.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening. So, children, this is from NCERT, the last exercise from NCERT. And this example or these examples are the examples preceding that exercise. The examples preceding exercise 8.4. That's the last exercise in trigonometry in your NCERT maths textbook. All right. So let's see the first one. Express the ratios cos A, tan A, and secant A in terms of sin A. You must express cos A in terms of sin A, tan A in terms of sin A, and secant A in terms of sin A. Fine. So now how do we write cos A in terms of sin A? Okay. Can you tell me an identity which connects sin theta and cos theta or sin A and cos A? Yes. An identity that connects.
Sin square theta plus cos square theta is equal to 1.
Very good, Ram. Yes. Sin square A plus cos square A is equal to 1. Sin square A plus cos square A is equal to 1. Now we have to write cos A in terms of sin A. So that means cos square A is equal to what? Cos square A is equal to, quickly. Cos square A is equal to
1 minus sin square.
1 minus sin square A. So what is cos A then? Cos A is equal to, yes.
Square root of 1 minus sin square.
Very good. Square root of 1 minus sin square A, because cos square A is nothing but cos A the whole square. Cos square A is nothing but cos A the whole square. So cos A the whole square is equal to 1 minus sin square A. So cos A is equal to the square root of 1 minus sin square A. And here we have written cos A in terms of sin A. See, sin A doesn't mean you should have only sin A. It can be sin square A, sin cubed A. In terms of sin A, cos A in terms of sin A. So here you can see we have written cos A in terms of sin A. And there can be any constant. Now there is one. There can be a constant along with sin A. There should be no other ratio. There should be no other ratio. So here see, we have cos A in terms of sin A. There is one. That's a constant. That's okay. So this is how we write cos A in terms of sin A. Is this understood?
Yes, ma'am.
Okay. Now
Yes,
next we have to, okay, good. Next we'll have to write tan A in terms of sin A. Tan A in terms of sin A. How do you write tan A in terms of sin A? What is tan A, children? What is tan A? Sin A by cos A, correct? Is tan A sin A by cos A?
Yes, ma'am.
Very good. So
Yes,
tan A is equal to, very good, tan A is equal to sin A by root of 1 minus sin square A. So we've written tan A in terms of sin A. We've written tan A in terms of sin A. Tan A is equal to sin A by cos A. And cos A we've already found in terms of sin A. We have already found cos A in terms of sin A, root of 1 minus sin square A. So sin A by root of 1 minus sin square A. So you can see tan A is in terms of sin A. Only sin we have there. And the last one is to write secant A in terms of sin A. Secant A in terms of sin A. Now, secant A in terms of sin A is, we already have cos A in terms of sin A. We already have cos A in terms of sin A. So what do we have? We have cos A. We don't write, children. I'll show you the answer slide. We already have cos A is equal to root of 1 minus sin square A. All right. So what is cos A? 1 by secant A. Cos A, cos and secant are reciprocal ratios. So cos A can be written as, the other way of writing cos A is 1 by secant A. They're the same. Cos A is equal to 1 by secant A. So instead of cos A, you can write 1 by secant A is equal to root of 1 minus sine square A. Now take reciprocals on both the sides. Now take reciprocals on both the sides. This one we already have. Cos A is equal to root of 1 minus sine square A. We just found. Now cos A can be written as 1 by secant A is equal to root of 1 minus sine square A. Now take reciprocals on both the sides. So 1 by secant A is equal to, the reciprocal of this one is 1 by root of 1 minus sine square A. So like this, we have written secant A in terms of sine A. We have written secant A in terms of sine A. Yes, children, please take down. Okay, so I presented in a different way. The understanding is the same. Yeah, please go through the slide, understand, and then take down. For the last one, my presentation is different, but the same idea. Just a minute, children. Done, children? Yeah. Now, prove that secant A into 1 minus sine A into secant A plus tan A is equal to 1. Now tell me, the rule is if there is something common, we'll have to take out the whatever is common. Otherwise, when you don't even have square, see, they're very simple. Secant A, sine A, tan A. So there is another rule which says write other ratios in terms of sine and cos. Write other ratios in terms of sine and cos. Yes or no? So you can write secant A as what? Secant A is what?
1 by cos A.
1 by cos A.
1 by cos A. Children, if there is something common, take it out. There are some rules. How to start? There are some rules. If there's something common, bring it out. Otherwise, write the other ratios in terms of sine and cos. So secant A can be written as 1 by cos A. Next, into 1 minus sine A. It's already 1 minus sine A, meaning it's already in sine A. So don't change. Now, what is secant A here? What is secant A?
1 by cos A.
1 by cos A. Very good. 1 by cos A. Don't write. Plus, what is tan A?
Sin A by cos A.
Sin A by cos A. I'm so happy that I'm getting answers. Very good. This is the LHS. This is the LHS. Don't write is equal to 1. You'll have to prove it's equal to 1. So now what is the rule we've used? We've written all the other ratios in terms of sine and cos. All right. Then 1 by cos A into 1 minus sine A. See, nothing can be done with this. Into here we can take the LCM. So cos A is the common denominator. So you get 1 plus sine A. 1 plus sine A. Close it. Now see, it's a product everywhere. If you want, I can just write it like this for you. 1 minus sine A divided by cos A, because it's multiplication. I hope you understand. When you have 1 by A into B, it's nothing but B by A. 1 by A into B is nothing but B by A. So 1 by cos A into 1 minus sine A is 1 minus sine A by cos A. Into, you can use this for better clarity, into 1 plus sine A. Just removing the bracket so that you can understand better. That's all. This is what is the meaning. This is what we have. 1 minus sine A by cos A into 1 plus sine A by cos A. Now this is multiplication. It's not common denominator cos A. You'll have to multiply the numerators and multiply the denominators. Now don't say common denominator cos A. Common denominator cos A is only when it's addition or subtraction. This is multiplication. Multiply the numerators. 1 minus sine A into 1 plus sine A. 1 minus sine square A, because A plus B into A minus B is A square minus B square, divided by cos A into cos A, cos square A, cos square A. Now you can do two things. Either you can write 1 minus sine square A as cos square A by the identity, by cos square A, which is 1, cancels and 1. Or you can also write 1 minus sine square A as it is and write cos square A as 1 minus sine square A. Anything is fine. Write the numerator 1 minus sine square A as it is. And you can write cos square A as 1 minus sine square A by the identity. So they get cancelled and it's equal to 1, which is the RHS. So what is the rule? What is the rule? Write other ratios in terms of sine and cos. That's it. Just use that rule and get started. And once you get started, that will lead you to the next step and you will finish it. Right on, children? Done, children?
1 minute.
Yeah. Okay.
Completed, ma'am.
All right. Yeah, this is the next one. Prove that cot A minus cos A by cot A plus cos A is equal to cosecant A minus 1 by cosecant A plus 1. Okay, so take up the LHS. Do not write, children. Listen to me. Take up the LHS. LHS is equal to cot A minus cos A by cot A plus cos A. So there's nothing common. So then what's the next rule? Write other ratios in terms of sine and cos. So what is cot A? What is cot A?
Cos A by sin A.
Cos A by sin A. Cos A by sin A minus cos A divided by, again, what is cot A?
Cos A by sin A.
Cos A by sin A. Cos A by sin A minus, sorry, plus cos A. Now tell me. Let me check how smart you are, all of you. Now, what is the next step? What is the next step? Is there anything common in the numerator and denominator? Okay, in the numerator, is there anything common?
Cos A.
Cos A and
Yeah,
Cos
take
A.
it out. Whenever there's something common, take it out. Cos A is common, take it out. So what in the bracket?
1 by sin A minus
1 by sin A.
Very good. 1 by sin A minus 1 divided by, what's common in the denominator?
cos A.
Cos A.
Cos A is common. Cos A is common.
Into
Whenever there is something
plus 1.
common, take it out. Take it out. Cos A into 1 by sin A plus 1.
Plus-
Now what's the next step?
Cancel we can
Yeah,
cancel.
cos A. Cos A in the numerator and denominator gets cancelled. Now look at what you have and look at the RHS, children. Minus 1 plus 1. You have minus 1 plus 1. Just look at the RHS. That will tell you what to do next. Look at the RHS. You're so close. Minus 1 plus 1 we have. There it is cosecant here. A and but here it is
Ma'am, 1 by
sin
sin
A.
A is
Now 1 by
cosecant
sin A
A.
is equal to cosecant A.
Cosecant A, that's all. So we should not take the LCM. Don't take the LCM. Normally we take the LCM, right? So always keep looking at the RHS because we need to start with the LHS and arrive at the RHS to prove the trigonometric identity. So as you work, keep looking at the
Sin A
RHS.
is
1 by sin A is cosecant A. So directly cosecant A minus 1 by, again 1 by sin A is cosecant A. So cosecant A plus 1 finished, see, is equal to the RHS. Hence proved. Please write down, children. Please write it one below the other. It's not that you should make, I'm sure you all understand. So don't write it like this. Don't put a line and write it beside. You keep continuing below. You keep working below. Done, children?
Yes, ma'am.
Yeah. See the next one. Prove that sine theta minus cos theta plus 1 by sine theta plus cos theta minus 1 is equal to 1 by secant theta minus tan theta. Write down. So whenever the identity on one side, so if you look at this identity, this is a trigonometric identity. This one is a trigonometric, this one is a trigonometric identity. And we need to prove this identity. Now, whenever, are we all listening? Class, use the emoji, raise your hand. Ramnathan, Nandini, Priyanka, Hitesh, Rajeshwari, Harini, Sneha, Ananya, Kanishka, Shreyas, Netra, Murli Krishna, Taran Murli. Very good, students. All right. So this information is for those who missed the last class. That is, I did not conduct a class on Thursday. So Tuesday's class, children, though I started the recording, I was unable to download the meeting recording, meaning it was not recorded. Though I started the meeting, though I recorded the meeting, I could not, the file was not saved. There was some error in recording. So those who missed Tuesday's class, I can only share the notes, meaning I can share the pictures of the questions and answers which were explained in that class. I don't have the recording. It's never happened like that so far. That was the first time. Yeah, so today I'll send the pictures. So students who missed the class on Tuesday can complete the notes from that. I'm sorry, I don't have the recording. Yeah, and talking about yesterday's class, children, can I compensate Thursday's class tomorrow evening from 7:30 to 9? Yeah, now lower your hands and raise your hand if it's okay. I'll give you a minute's time to think about it. I would like to compensate Thursday's class tomorrow evening from 7:30 to 9. Tomorrow evening from 7:30 to 9. Please lower your hands and raise your hands if it's okay for you. Okay, so Ananya is fine. Rajeshwari is fine. Okay, so Harini and Sneha cannot take up the class. Is it tomorrow? Reason?
Monday we are having exam, ma'am.
Okay. What about Netra?
So, ma'am, I don't have exam on Monday.
You two have an exam on Monday, is it?
Yes.
Okay. What about Shreyas?
Ma'am, I do have an exam from Monday, ma'am.
Okay. Okay. Can I? Do you have exams? All of you, Harini, Sneha, Netra, and Shreyas, you all have exams the whole of next week?
Yes, ma'am. Till next Monday we are having, ma'am.
I'm also having exam on Monday.
Yeah, correct. Okay. So which means Harini, Sneha, Netra, and Shreyas, will you all take up the classes next week or no?
Ma'am, I think I won't come for classes, ma'am.
Netra, next week?
Ma'am, if it is an easy subject and we are okay in that, we can attend, ma'am.
Okay. Netra, next week?
Yes, ma'am, my exam gets over on Friday.
What about Shreyas?
Ma'am, same reason. It depends upon the subject only.
Subject you have. Okay. Fine. Now, will it be fair if I say that I'll go ahead with the compensation class tomorrow and those who will not be able to attend should make use of the meeting recording? Will it be fair if I say that? Fair or not fair? because those of you who will not be able to attend tomorrow have exams next week, which means next week also I will not be able to do the compensation class. I don't want to postpone for a very long time. Then what happens, I'll forget. Then it will be like I promise and I break my promise. I'll forget about the compensation class. Okay, so this is what I feel. I want to go ahead with the compensation class tomorrow evening, and children who cannot take up the class tomorrow can make use of the meeting recording.
Okay, ma'am.
Okay, thank you. Yeah, that's nice. You acknowledged. Thank you. Yeah. Okay, that's what for Shreyas and Netra also. Kindly make use of the meeting recording. 7:30 to 9 in the evening. So maybe if you start studying from tomorrow morning, you'll be tired with your preparation. And I think you can take up the class. Just try your best, all of you, because it's towards the end of the day. So work hard from morning and try to finish off your revision by 7 o'clock so that you can take up the class at 7:30. Try your best, the four of you.
What is the timing, ma'am?
7:30 to 9 in the evening.
Okay, ma'am.
Yeah. All right, children. So I was talking about this one. In this identity, you see the left-hand side is made up of sine theta, cos theta, and 1. Listen very carefully. In this identity, the left-hand side of the identity is made up of sine theta, cos theta, and 1. Sine theta, cos theta, and 1. Now, when you have an identity like this, what you have to do is take the help of the other side of the identity, that is the RHS. The RHS is made up of secant theta and tan theta. Now the rule is you have to divide. You will have to take up the LHS. You will have to divide the numerator and denominator either by sine theta or by cos theta. Now you have to make a decision. Should you divide the numerator and denominator by sine theta or by cos theta? To decide that, you'll have to take the help of the RHS. The RHS is made up of secant theta and tan theta. So you must get the same thing in the left-hand side. So now supposing we divide by sine theta. So sine theta by sine theta is 1. Cos theta by sine theta is cos theta by sine theta is cot theta. And 1 by sine theta is cosecant theta. You're getting cot theta and cosecant theta, cot theta and cosecant theta. But in the RHS, it is secant theta and tan theta. So you should not divide by sine theta. You should divide by cos theta. Now let's check that. Divide the numerator by cos theta, cos theta. Sine theta by cos theta is tan theta. Cos theta by cos theta is 1. And 1 by cos theta is equal to secant theta. See that? You should do the same thing in the denominator. Sine theta, divide both the numerator and the denominator by cos theta, which means you have to divide every term in the numerator and every term in the denominator by cos theta. So same thing you will get. Sine theta by cos theta is tan theta. Cos theta by cos theta is 1. 1 by cos theta is secant theta. You will get the same thing. Same thing meaning you will get the same ratios tan theta and secant theta. I'll repeat this. Now, whenever in the identity, one side of the identity, it can be the LHS or the RHS. So here the LHS is made up of sine theta, cos theta, and 1. The numerator has sine cos 1. The denominator also has sine cos 1. Now, in this case, we have to divide both the numerator and denominator by sine theta or cos theta. Now, we have to make a decision. Should we divide by sine theta or by cos theta? For that, you need to take the help of the other side, the RHS. In the RHS, we find the ratios secant theta and tan theta. That means you must get the same ratios in the left-hand side. You must get secant and tan. Now, when will you get secant and tan? When you divide by sine or when you divide by cos? So you should just try that. You must just do that mentally. So do it in your mind. Sine theta by sine theta. Do that in your mind. And I'm showing you on your screen. So what is sine by sine? 1. What is cos by sine? Cot. There itself you can stop. You're getting cot. You don't have cot here. You can stop there itself. 1 by sine is cosecant. No, you're getting cot and cosecant. No, we don't want cot and cosecant. We want secant and tan, which means you have to divide by cos theta. You have to divide by cos theta because sine theta by cos theta is tan theta and 1 by cos theta is equal to secant theta. Do you all understand that, children? Say yes or no. Yeah.
Yes.
So, very nice. So that is the first step. We divide the numerator and denominator by cos theta. Yeah. Now, since the the proof is really big, I cannot work on this slide. I have to make use of the answer slide. For the small one, I can just work it there. So see here, children, ignore this. Just leave this. Look at the left-hand side. Look at the left-hand side. Ignore this one, children, for now. Take up the left-hand side. I'm talking about this one. So LHS. So what is the LHS? Sine theta minus cos theta plus 1 by sine theta plus cos theta minus 1. Whatever is the LHS. See, this is the left-hand side. This is the left-hand side. I've written it as it is. I've written the left-hand side as it is. Now, divide the numerator and denominator by cos theta. You can see it there. I've divided by cos theta. So that means so this is dividing the numerator and denominator by cos theta. In the next step, it will be sine theta by cos theta minus cos theta by cos theta plus 1 by cos theta. Dividing every term in the numerator by cos theta. Similarly, divide every term in the denominator by cos theta. So sine by cos by cos, 1 by cos. Please check if you understand. We have discussed the first 3 steps. Tell me if you understand 1, 2, 3. Tell me if you understand 1, 2, 3. 1 is the LHS. 2 is dividing by cos theta. 3 is dividing every term in the numerator and denominator by cos theta. In the next step, what is sine theta by cos theta? Tan theta. What is cos by cos? 1. What is 1 by cos? Secant. Same thing in the denominator. Sine by cos is tan. Cos by cos is 1. 1 by cos is secant. That's the next step. That is the next step. Till here we have discussed. Now, after this, you know what, children? The denominator, don't disturb the denominator. The denominator will come like that till the end. Don't worry about the denominator. Now we are going to work only with the numerator. See, these are standard ones. So you will get used to it. When you practice it once or twice, you'll get used to it. Now it will be like, how do I know that I have to do that next? So with practice, you will be able to remember. See, I'm telling you a story for every step. I'm not just telling you like that. I'm telling you a story for every step. So now after this, once the, the terms are converted to tan and secant, do not disturb the denominator. Work only with the numerator. In the numerator, what you have to do is, in the numerator, so see the denominator, children? See the denominator? I've just rearranged the terms. You can just rearrange denominator. You can rearrange the terms the way you want, or you can have it as it is. You can just write it like this itself, tan theta plus 1 minus tan theta plus 1 minus secant theta as it is also. Not that you must change this to this one. You can write it as it is also. Okay. All right. So now what we do is, once the ratios are converted to secant and tan, do not disturb the denominator. Leave the denominator as it is. What I have done is I've just rearranged the terms, 1 and then I've written secant and then tan. You can write it as it is. The same thing you can write in the denominator. Okay, now in the numerator, what do we do in the numerator? Write it 1 in the end. This minus 1, no? Write it in the end. So you have what? Secant theta plus tan theta minus 1. See, the identity is secant square theta minus tan square theta is equal to 1, right? So in which secant theta comes first and then tan theta. That's why I've written secant first and then tan. In the identity, secant square theta minus tan square theta is equal to 1. See, it's very easy to remember like this. All is equal to 1. So in this identity, secant square theta minus tan square theta is equal to 1. We have secant first and then tan. So that's why I've written secant here. So see, a secant theta plus tan theta in a bracket and minus 1 outside. Now this minus 1, write this minus 1 as secant square theta minus tan square theta in the next step. Because 1 is nothing but secant square theta minus tan square theta. See, 1 is also cosecant square theta minus cot square theta, but that's not relevant to this situation. Since we have secant and tan, we'll write 1 as secant square theta minus tan square theta. That's the next step. See here, that's the only change. That's the only change. This minus 1, you know, this minus 1, we write it as secant square theta minus tan square theta. See here, secant theta plus tan theta as it is, as it is. This minus as it is, minus. And instead of 1, secant square theta minus tan square theta. Denominator as it is. So what have we done in the numerator? Nothing. Instead of 1, we have written secant square theta minus tan square theta. That's all. And we have just grouped the remaining ratios as secant theta plus tan theta. Secant first and then tan. Now, next step. You know that secant square theta minus tan square theta is like a square minus b square or x square minus y square, which is x plus y into x minus y. So see here, write the secant theta plus tan theta as it is. This minus sign as it is, minus as it is. A square minus b square is a plus b into a minus b. So secant square theta minus tan square theta is secant theta plus tan theta into secant theta minus tan theta. Denominator as it is. No change in the denominator as it is. Next, what you'll have to take out common. What is common? So I've just called this whole thing x, children. You can see that. And here also you see the same x. Secant theta plus tan theta, I've called it x. And secant theta minus tan theta, I've called it y. Just to make it easy for me to explain. So when there is something like x minus x, see, I've called this one x. Secant theta plus tan theta as x. Plus tan theta as x. This is different. Secant theta minus tan theta, I've called it y. All right. Now, when you have x minus xy, x is common. In the bracket, you'll get 1 minus y. X minus xy, x is common. In the bracket, you'll get 1 minus y. Same thing here. See here, secant theta plus tan theta is common. X is common. See, you can use the same thing. X minus xy, x minus xy. X is common. That is secant theta plus tan theta is common. See, x minus xy, x is common. In the bracket, 1 minus y. So you can see here in the bracket 1 minus y. Please understand. X is common. In the bracket 1 minus y. See here now when you multiply. Secant theta plus tan theta into 1 is secant theta plus tan theta. Minus secant theta plus tan theta into secant theta minus tan theta is this one. Just taking out secant theta plus tan theta common, that's all. And I've also showed you x minus xy. X is common. In the bracket, you will get 1 minus y. 1 minus y. You don't have to write all that. You can write it now, but in the exam, don't write that. You can write it in your books now to understand. So secant theta plus tan theta is common, and this is what you get in the bracket, denominator as it is. Now, next step, the secant theta plus tan theta, and here you get 1 minus secant theta plus tan theta. When you remove the bracket, minus secant theta plus tan theta, minus secant theta plus tan theta. Now you see that this gets cancelled. You have the same expression in the denominator. You have the same expression in the denominator. Gets cancelled. So we get secant theta plus tan theta. We get secant theta plus tan theta. Now work the RHS. Work the RHS. What do you have in the RHS? 1 by secant theta minus tan theta. So in the denominator we have a minus. So we'll multiply and divide by secant theta plus tan theta. Secant theta plus tan theta. So when you do that, 1 into secant theta plus tan theta is secant theta plus tan theta. When you multiply the denominators, a plus b into a minus b is a square minus b square. Next step, you know that secant square theta minus tan square theta is 1. Secant square theta minus tan square theta is 1. So numerator secant theta plus tan theta by 1, which is nothing but secant theta plus tan theta. So I've called this 1, I've called this 2. From 1 into, you can see when we simplify the RHS, we get secant theta plus tan theta. When we simplify the LHS, we get the same thing, secant theta plus tan theta. 1 is equal to 2. LHS is equal to RHS. Very easy, children. Very, very easy. Write down. I'll tell you again. Please write down. You can work the LHS and then the RHS. You can work the LHS and then you can work the RHS. Now, supposing you want to continue with the LHS, children, 1 minute, I just want to say something else. Now, supposing in some cases you can do that, you can even continue with the LHS and get the RHS as the answer. See here, I'll continue with the LHS, okay? Here, I'll continue with the LHS. What is the LHS? Supposing we have not worked this, children. Children, supposing we have not worked this, Okay, this one, I've not worked the RHS. So what have I got? When I work the LHS, what have I got here? Now we don't say we don't stop here, okay? We don't stop here. So we've got secant theta plus tan theta. We have to work ahead. What's the RHS? 1 by secant theta minus tan theta. But I've got only secant theta plus tan theta. So I have to work ahead. I haven't got the RHS, right? So I have secant theta plus tan theta. So how do you continue? How do you continue? So we have is equal to secant theta. We have secant theta plus tan theta. How do you continue? Multiply and divide by secant theta minus tan theta. Multiply and divide by secant theta minus tan theta. Now what will you get is equal to multiply the numerators. Secant theta plus tan theta into secant theta minus tan theta. A plus b into a minus b. A squared minus b squared divided by secant theta minus tan theta. So you know that a square minus b square, that is secant square theta minus tan square theta is 1. 1 by secant theta minus tan theta, which is equal to the RHS. You can also complete it like this. I think you can do it like this. Yeah, don't work this, children. It's not wrong. Please, this is not wrong. You can also do it like this. You can take down both the methods. Now it's left to you. Yeah, please write down, children. I'm just coming back. Please write. Done, children?
1 minute, ma'am.
Okay. Understood both, huh? Please be honest. Okay, complete writing and any questions, please ask me. Yeah, done writing. Yes, yes, children, hurry up. Yeah, any questions? Yeah, you'll have to reply, children. Please respond. Any questions?
No, ma'am.
No. Okay. So I'll just brief the procedure again. So I was telling you that when either the LHS or the RHS of the identity is made up of sine theta, cos theta, and 1. It may be the LHS, it may be the RHS. So here the left-hand side of the trigonometric identity given is made up of sine theta, cos theta, and 1. That is, the numerator has sine theta, cos theta, and 1. The denominator also has sine theta, cos theta, and 1. Then the procedure is to divide both the numerator and denominator by either sine theta or cos theta. So whether it is sine or cos, you'll have to decide that by looking at the other side of the identity. That is here the RHS. In the RHS, we have the ratio secant theta and tan theta. So you must choose accordingly, which will give you secant and tan in the left-hand side. So here, when you divide the numerator and denominator by cos theta, the left-hand side is converted to tan and secant. When you divide the numerator and denominator by cos theta, you can see that the ratios are converted to tan and secant in both the numerator and denominator. So this is one part accomplished. Now, how do you proceed? Now, once you get tan theta and secant theta, do not disturb the denominator. See, I have rearranged these terms. You don't even have to rearrange. You can just write it as it is. Okay, the denominator not disturb. In the numerator, you group this secant theta and tan theta. Put that in a bracket. And this minus 1 outside. And next, what you're going to do is, you're going to remove that minus 1, meaning 1. And write and replace 1 with secant square theta minus tan square theta. You're going to replace 1 with secant square theta minus tan square theta. That's the next step. Denominator as it is. Next, secant square theta minus tan square theta is secant theta plus tan theta into secant theta minus tan theta. Now common, secant theta plus tan theta is common, and then you have this in the bracket. And when you open up the bracket, you see that the expression in the numerator and denominator is the same. So cancels. And you have secant theta plus tan theta. You can continue with that. Continue because we have not still got the RHS. So continue. Multiply the numerator and denominator. Here the denominator is 1. There's nothing, so it's 1. By secant theta minus tan theta. It's plus here, so multiply by secant theta minus tan theta. So when you multiply the numerators, you get secant square theta minus tan square theta. Denominator secant theta minus tan theta. And this is 1 by the identity. The numerator is 1 by the identity. 1 by secant theta minus tan theta, which is the RHS. So you have two ways of finishing the proof. You can either stop there and take up the LHS, work that, show that the LHS is equal to the RHS also. Okay. Express the trigonometric ratios sin A, secant A, tan A in terms of cot A. Express the trigonometric ratios sin A, secant A, tan A in terms of cot A. So you must write sin A in terms of cot A. You must write sin A in terms of cot A. Now, how do we connect sin and cot? Even if you cannot connect sin and cot, what's a reciprocal of sin? Reciprocal of sin, cosecant. You can connect cosecant and cot. So when you write cosecant in terms of cot, easily you can write sin in terms of cot. We have to write sin in terms of cot, sin A in terms of cot A. Now there is no identity that connects sin and cot directly, sin and cot directly. So what's a reciprocal of sin? Cosecant. Oh, sorry. Oh, yeah, cosecant A. Okay, the reciprocal of sin is cosecant A. Okay, now we cannot connect sin and cot, but the reciprocal of sin A, which is cosecant A. Cosecant A and cot A, yes, they are connected through an identity because cosecant square A minus cot square A is equal to 1. So the idea is we'll take up this identity, we'll write cosecant A in terms of cos A, cot A. We'll write cosecant A in terms of cot A, and cosecant is nothing but 1 by sin. All right. So once you write cosecant in terms of sin, my God, 1 second. I need to clear my throat just a second. Yeah, thank you. So once you write cosecant A in terms of cot A, you can easily write sin A in terms of cot A. So see here, we start with this identity. Cosecant square A minus cot square A is equal to 1. Tell me what next. Write cosecant A in terms of cot A. Write cosecant A in terms of cot A fast. Excuse me. Children, please write cosecant A in terms of cot A. No, I don't know. You don't know or you're lazy to talk? What is up? Please answer, children. Huh? What is this?
Ma'am, I can't hear you for last 5 minutes, ma'am.
Oh my God. What about the others? Am I audible?
Yes, ma'am.
Yes, ma'am.
Okay. So Sneha and Harini, what I was saying is we have to write sin A in terms of cot A. For that, we are going to, since cosecant and cot are connected through this identity, cosecant square A minus cot square A is 1. And what is cosecant A? It's 1 by sin A. So we are trying to write cosecant A in terms of cot A and then write sin A in terms of cot A because cosecant A is equal to 1 by sin A. Now my question to the class is, please help me write cosecant A in terms of cot A, please.
Ma'am,
Yeah.
from square root of 1 plus cot square.
Yeah, tell me cosecant square A is equal to?
1 plus cot square.
Yeah, thank you, Rajeshwari. Yes, then what is cosecant A?
Square root of 1 plus cot square.
Now what is cosecant A?
1 by sin A.
Very good. 1 by sin A is equal to root of 1 plus cot square A. Now take reciprocals on both the sides. What is sin A then? Is equal to?
1 by
1.
square root of 1 by cot square.
That's it. Thank you so much. You came to my rescue. Thank you, Rajeshwari. That's all it is. So you have to write sin A in terms of cot A. Sin and cot, they're not connected through an identity. So the reciprocal of sin is cosecant. Cosecant and cot are connected through this identity. Cosecant square A minus cot square A is 1. So write that identity and write cosecant A in terms of cot A. Then change cosecant A to 1 by sin A and write sin A in terms of cot A. That's all. Next, we have to write secant A in terms of cot A. Secant A in terms of cot A. Again, connect. See, you need to now secant A in terms of cot A. So you should connect secant and cot. If not secant and cot, they're reciprocals. They're reciprocals. The reciprocal of cot A is tan A. So secant square A minus tan square A is 1. Secant square A minus tan square A is 1. See, you connect secant A and cot A. If that's not possible, connect their reciprocals. So secant A minus the reciprocal of cot is tan and secant square A minus tan square A is 1. So what is secant square A? Secant square A is equal to 1 plus tan square A. And what is secant square A is equal to 1 plus what is tan square A? 1 by cot square A. That's it. We got secant in terms of cot. We have to still continue. But I'm telling you, we got it in terms of cot. That's all. If you cannot connect the two ratios, secant and cot, connect the reciprocals. So you have to write secant A in terms of cot A. So secant and cot, there's no identity that connects these two. But you know that secant square A minus tan square A is equal to 1. We'll go ahead with this because tan you can write it as 1 by cot. Reciprocals, cot and tan are reciprocals. So go ahead. Secant square A is equal to 1 plus tan square A. Okay. So secant square A is equal to 1 plus 1 by cot square A. Then take the LCM and square root on the other side, and then you get, secant A in terms of cot A. I'll show you the slide. We'll have to continue like this. And the last one, tan A in terms of cot A. How to write tan A in terms of cot A? Tan A is equal to 1 by cot A. That's all. How do you write tan A in terms of cot A? Tan A is equal to 1 by cot A. Finished. Write down, children. Write down. You can see just what I explained. One minute. Write down the question and write this like this. cosecant square A minus cot square A is equal to 1. For the first one, please write it like this. Cosecant square A is equal to, okay, 1 minute. That means I'll just write that step in the numerator. 1 minute. Just start like this. Cosecant square A minus cot square A is equal to 1. Start like this. Then cosecant square A is equal to 1 plus cot square A and all that. All right. So when you take the square root here, when you take the square root on this side, what will happen? The numerator comes as it is, 1 plus cot square A. The denominator, square root of cot square A is cot A. That's why the square root is only for the numerator, not for the denominator. The square root is only for the numerator, not for the denominator, because the square root of the numerator as it is. Denominator cot square A is cot A. So cot A out of the square root. Here also you can just write, first you can start with secant square A minus tan square A is equal to 1. You can start with that. Secant square A minus tan square A is equal to 1. Done, children?
Yes, ma'am.
So this is how we write, trigonometric ratios in terms of the other. So here sin A, secant A and tan A in terms of cot A. So I think this will be your homework, children. Write the other trigonometric ratios of A in terms of secant A. I have the answer for you. Please help yourself. So we'll have to write the other trigonometric ratios of A in terms of secant A. That is, you should write sin A in terms of secant A, cos A in terms of secant A, all the other ratios. You must write sin A. See, you should write sin A in terms of secant A, cos A in terms of secant A. See here, cos A in terms of secant A, tan A in terms of secant A, then cosecant A in terms of secant A, and cot A in terms of secant A. See, you have sin A, cos A, tan A, cosecant A, secant A, cot A. These are the 6 ratios. You have to write secant A in terms of sin A, cos A, tan A, cosecant A, and cot A. Sorry, you'll have to write sin A, cos A, tan A, cosecant A, and cot A in terms of secant A. In terms of secant A. So that is, you should write all the other 5 ratios. All the other 5 ratios in terms of secant A. In terms of secant A. So you can see here, I've taken this identity, sin square A plus cos square A is equal to 1. And we know that cos can be written as 1 by secant square A. Cos and secant are reciprocal ratios. So cos square A can be written as 1 by secant square A. So sin square A is equal to 1 minus 1 by secant square A, LCM, secant square A. So in the numerator, you get secant square A minus 1. So sin A is equal to square root of secant square A minus 1 by secant square A. So sin A is equal to square root of the numerator as it is. Square root of the denominator is secant A. Square root of the denominator is secant A. So we have written sin A in terms of secant A. Sin A in terms of secant A. See, we'll have to write all the ratios. Sin A, cos A, tan A, cosecant A, and cot A in terms of sin A, secant A. In terms of secant A. So first we're writing sin A in terms of secant A. How? We make use of this identity. Sin square A plus cos square A is 1. There is sin A here. Where is secant A? Cos square A is 1 by secant square A. So see, in this identity, we have sin square A and secant square A. Now we are going to write sin A in terms of secant A. So for that, we'll have to transpose this. 1 minus 1 by secant square A. Common denominator. Then sin square A is this one. So sin A is the square root of the RHS. So you can see the square root of the numerator as it is. Square root of the denominator is secant A. So we have written sin A in terms of secant A. Once you write sin A in terms of secant A, immediately write cosecant A in terms of secant A, the reciprocal of sin A. Once you write sin A in terms of secant A, immediately write the reciprocal of sin A, that is cosecant A, in terms of secant A. So what is cosecant A? Cosecant A is 1 by sin A. Cosecant is the reciprocal of sin. Cosecant A is 1 by sin A. All right. And what is 1 by sin A? The reciprocal of this. The reciprocal of this one. Secant A by root of secant square A minus 1. So that way we've written cosecant A. Cosecant A in terms of secant A. This is cosecant A in terms of secant A. Because cosecant A is 1 by sin A. And 1 by sin A meaning the reciprocal of sin A. This is the reciprocal of sin A. Secant A by root of secant square A minus 1. So we have written cosecant A in terms of secant A. So we finished sine and cosecant. Cos. Cos is equal to 1 by secant A. Cos in terms of secant. Cos A is 1 by secant A. So we have finished sine, we finished cosecant, and we finished cos. We are left with secant and tan and cot. Tan and cot. We're left with tan and cot. We'll have to write tan in terms of secant, cot in terms of secant. Okay. So tan and secant, they're directly connected with this identity. Secant and tan. So secant square A minus tan square A is 1. Tan square A is equal to secant square A minus 1. Tan A is equal to square root of secant square A minus 1. So we have written tan A in terms of secant square A. Now cot A, 1 by tan A. So the reciprocal of this one. Reciprocal of this one. 1 by root of secant square A minus 1. So like this, we have written sin A, cosecant A, cos A, tan A and cot A in terms of secant A. In terms of secant A. So using this identity, you can write tan in terms of secant. Tan in terms of secant. Once you write tan in terms of secant, immediately you can write cos or cot also in terms of secant. Because tan and cot are reciprocal ratios. Once you write tan in terms of secant, immediately write cot in terms of secant. And then here using this identity, sin square a plus cos square a is 1. And cos square a is 1 by secant square a. So you can write sin a in terms of secant a. Once you write sin a in terms of secant a, immediately write its reciprocal, cosecant a in terms of secant a. Reciprocal. So using this identity, we wrote tan in terms of secant and immediately wrote cot in terms of secant. Using this identity, we wrote sine in terms of secant and the reciprocal of sine, cosecant in terms of secant. We finished 4 like that. And the 5th one is cos a, 1 by secant a, reciprocal. That's all. Take a screenshot, children. Complete this. Yeah. Let me see who can give me this answer. Please work 1. Work subdivision 1. They're not standard angles, so you cannot pull the values from the table. You have to use the concept of complementary ratios. Complementary ratios. So you need to plan and then execute it. Please try and share your answer with me. Yes, done. Some of you already learned trigonometry in school. I forgot. I remember Ananya saying that she's learned trigonometry in school. Who else? Who else has learned trigonometry at school? Nobody else? Nobody. All right. Except Ananya. Still. Huh. I gave you the clue. Use complementary ratios. First plan. What is sine theta? What is sine theta? When I ask you what is sine, Yeah, that's what I want, the most relevant answer. We are talking about complementary ratios. Now you shouldn't be like, what does she mean by what is sine theta? So with respect to complementary ratios, sine sine theta is equal to cos 90 minus theta. Who said that? Rajeshwari, is it?
Yes, ma'am.
Very good. So sine theta is equal to cos 90 minus theta. And what is cos theta?
Sine 90.
Sin 90.
Sine 90 minus theta. Sine 90 minus theta. So sine theta is equal to cos 90 minus theta. When you square this on both the sides, you get sine square theta is equal to cos square 90 minus theta. Similarly, cos theta is equal to sine 90 minus theta. When you square on both the sides, you get cos square theta is equal to sine square 90 minus theta. So what should occur to us is that probably we can convert this to the identity sine square theta plus cos square theta. So you will get one in the numerator and one in the denominator. So 1 by 1, which is 1. Let's see. Maybe we have sine square 63 here. Let's not disturb this. Let's convert this one. So what is and the denominator also. Maybe you can change this one to sine and have this as it is. See, you can in the numerator and denominator change any one. There is no rule that you'll have to change this one only. You choose which to decide. You choose which to change. Change any one. Don't change both at the same time. Okay, so in the numerator, say in the numerator, say we write sine square 63 as it is. We write sine square 63 as it is. Okay, plus now sine square 27 degrees. Sine square theta is equal to cos square 90 minus theta, 90 minus 27. Sine square theta is equal to cos square 90 minus theta. So sine square 27 degrees is equal to cos square 90 minus 27. Divided by, in the denominator, supposing we change cos square 17. So cos square theta is equal to sine square 90 minus theta, 90 minus theta, which is 17. Plus write the other one as it is. Let's see if this is working. So that is the idea is, we think we'll get, the numerator and denominator to look like the identity sine square theta plus cos square theta, so that we can write one. So sine square 63 degrees plus cos square 90 minus 27 is 63. Yeah, divided by sine square 73, 90 minus 17 is 73 plus cos square 73. So it's like sine square theta plus cos square theta. See, the angle is the same, 63, 63. So it's 1 by the angle is the same, 73, 73. Sine square theta plus cos square theta, 1 by 1, which is 1. See, children, you can also do this. See, supposing you wish to have this sine square theta as it is, then change this one to cos square theta. Supposing you wish to have this cos square theta as it is, then change this one to sine square theta. Change any one, that's what I said. There is nothing that you'll have to change this one only or this one only, nothing like that. You decide. Now you want to make the numerator and denominator look like sine square theta plus cos square theta. So if you have this sine square theta as it is, change this one to cos square theta. In the denominator, if supposing you want to have this one as it is cos square theta, then change this one to sine square theta using complementary ratios. Yeah, please do please complete this one. We'll work the next one and wind up the session for today. Yeah, I wanted to, discuss this. Some schools, see, yeah, did you understand what I told you, children? All of you?
Yes, ma'am.
Yeah. Now this presentation, I see some schools, some teachers work it like this. The idea is the same, but the way they, use complementary ratios may be slightly different. Some teachers, what they do is, this is sine square 63, right? What they'll do, they'll write sine square as it is. What is 63? 90 minus 27. Please listen, you can change it in two ways. Now, in the numerator, we are changing this one. Anything you can change. That I already told you. There is no change with that. Okay, so we're changing this in the numerator and we're changing this one in the denominator. So we are not disturbing this and this. So you decide which one you want to change. So according to this working, we're changing this in the numerator and this in the denominator. So sometimes, this can be an alternate working. Teachers sometimes work it like this. What is that? Now, write sine square as it is. And what is 63? 90 minus what? See, you should write 63 as 90 minus something. 90 minus what? 90 minus 27. So write sine square as it is. And 63, we're just writing it in a different way. 90 minus 27. So we're not making any change there. Or we're writing sine square 63 as it is, sine square 63. We're writing sine square 63 as it is. Sine square, instead of 63, we're writing 90 minus 27. That's all. Okay. And in the denominator, write cos square 73. Write it as 90 minus 17. 90 minus what is 73? 90 minus 17 is 73. So instead of 73, see, write cos square as it is. Instead of 73, write its equivalent. 90 minus 17. Now after this, now this is like sine square 90 minus theta. Sine square 90 minus theta. What is sine square 90 minus theta? Cos square theta. So see in the next step, cos square theta 27. This is another way of presenting the usage of complementary ratios. This is like sine square 90 minus theta, which is cos square theta. So cos square theta 27. Cos square 27. And in the denominator, cos square 90 minus theta. Sine square theta. So sine square 17. Theta is 17. So sine square 17. So now numerator and denominator, like sine square theta plus cos square theta, which is 1. 1 by 1, which is 1. Yeah, please, I think it's time. Take a screenshot, children. Take a screenshot and complete this. Yeah, take a picture of this one also. You can help yourself. Please complete this also. Done, children?
Yes, ma'am.
Yeah. All right, children. Yeah, so that's it for today's session. Thank you so much. Good night.
Thank you,
Thank
ma'am.
you, ma'am.
Thank you, children. Good night.
Thank you.
Thank you.
Thank you, ma'am.
Thank you, children. Good night.